Well, hello and welcome to this exercise on the roots or zeros of quadratic equations. And this is based on an iGCSE additional mathematics question. And it says the equation x squared plus bx plus 1 is equal to 0. And it has roots alpha and beta. Okay, and it says find in terms of p an expression for alpha plus beta, alpha squared plus beta squared, and alpha cubed plus beta cubed. And then it says, find a quadratic equation with coefficients expressed in terms of p, which has roots alpha cubed and beta cubed. So we need to form a new equation. Okay, right. Now, this is our solution here. Now, to begin with, I've expressed the general format of a quadratic equation. And we know what A and B and C are. We also know, and hopefully remember, that the sum of the roots of a quadratic equation is given by minus a fraction formed by the coefficient of x as the numerator and the coefficient of x squared as the denominator there. So you got b over a and the minus sign there. We also know that the product of uh, the roots of the equation, in this case alpha times beta, is equal to the constant term divided by the coefficient of the x. This is the coefficient of x squared, in this case a. So for our first section here, alpha plus beta is going to be minus p over 1, which is same as minus p there. And that's the first section. The second section, we want to find alpha squared plus beta squared. So what I've done here is look at expanding alpha plus beta all squared. And when you expand that, you get alpha squared plus 2 alpha beta plus beta squared. Now I'm looking for just alpha squared plus beta squared. So I need to subtract 2 alpha beta from both sides. So we now end up with alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. Now we know that alpha plus beta is minus p. Okay, so alpha plus beta all squared will be minus p all squared. We also know that the product of alpha and beta is 1 because 1 divided by 1 is 1. The constant term is 1 and the coefficient of x squared is 1. So 1 over 1 is 1. So that becomes minus 2 times 1, which is minus 2. So we end up with this here. Minus p all squared minus 2. And when we simplify, we have that alpha squared plus beta squared is p squared minus 2. Okay, now following the same trend, we're looking for alpha cubed plus beta cubed. Now, this is what there's another method of doing this, but if we say that alpha plus beta all cubed, now if we now expand, if we now expand this expression here, we end up with alpha cubed plus 3 alpha squared beta plus 3 alpha beta squared plus beta cubed there. Now what I'm going to do now, I'm going to factorize the bit in red. Okay, so I now have alpha plus beta all cubed is equal to alpha cubed plus 3 alpha beta multiplied by alpha plus beta and then plus beta cubed there. As before, as in section 2, I want to get rid of this bit here because I'm looking for just alpha cubed plus beta cubed there. So to get rid of this alpha, so 3 alpha into alpha plus beta, I subtract this, the 3 alpha beta times alpha plus beta from both sides. So I now end up with alpha cubed plus beta cubed is equal to, or same as, alpha plus beta cubed minus 3 alpha beta times alpha plus beta. Okay, now alpha plus beta we know is minus p from section 1, where we find alpha plus beta. Alpha alpha plus beta is minus 1. Okay, and alpha beta is just 1, and again alpha plus beta is minus p again. So we've got minus p cubed minus 3 times 1 times minus p. So this is what we've got now. We got this here, minus p cubed minus 3 times 1 times minus p. So this leg will give us plus 3p, and that's going to give us minus p cubed. So now alpha cubed plus beta cubed then becomes 3p minus p cubed there. And if we wish, there's no reason why you should do that, but if you wish, you can factorize this, but it doesn't really matter. Okay, so that's section 3 of part A. Now for part B, we want to find an equation that has alpha cubed as a root and also beta cubed as a root there. Now, suppose that our new equation is x squared plus zx plus 1 is equal to 0. Now, z is the coefficient of x there. So what we then do is, we know that the sum of the roots of a quadratic equation is equal to minus the fraction formed by the coefficient of x, in this case z, divided by the coefficient of x squared, in this case 1. So alpha cubed plus beta cubed is minus z over 1, which is equal to minus z. We also know that alpha cubed plus beta cubed is equal to 3p minus p cubed. From there, okay, so 3p minus p cubed. Now, that means that minus z is equal to 3p minus p cubed, in which case z is equal to minus 3p minus p cubed. So if you now replace our z there by minus 3 plus p cubed, our new equation then becomes s squared minus 3p minus into 3p minus p cubed x plus 1 is equal to 0. And I hope all that made some sense. And please subscribe. Thank you for watching. And